Alright, after last night's lessons, I'm going to take what we learned there and try to address the issue, which was the ballast fusing and causing a almost impossible removal of the part. So I've constructed a different ballast with a little different blend. As you can see, it is a little lighter. It's also much more powder-like. There's a blend of talc here with alumina, with some other stuff here to hopefully give me the result that I'm looking for whenever we do the sinter and pre-sinter. So anyway, we're going to debind these in the standard kiln. We could do the microwave, but I'm going to do this overnight, and it's just easier in the regular kiln. And this one here is a aluminum part, just not functional or anything, just an aluminum larger lattice piece. And these two here are the 17-4 steel test rings, all printed in Virtual Foundry. And we're going to follow up the debind with a pre-sinter with a arc sinter. So let's see what happens. Well, this is interesting. It has formed a cake. This seems to be stuck to the cake here. Not really what I was expecting. We'll see if we can get this chiseled out. It does seem to be breaking apart. The problem, it may have been a little caustic. The element seems to be a lot more brittle now. It's just scraping away. So that's... Oh, pardon the sandblaster. Alright, the compressor turned off. Sorry about that. Yeah, so cracking it open, there seems to be a shrunken-in chamber in there. So this will be interesting to take a look at. I had to break my crucible to get this part, which is not ideal. So I don't know if this is going to be feasible, but anyway, we'll see what the results are. A little time has passed, and we are off to the next experiment. We're using the same ballast here, 17-4 steel test ring, same style crucible, and they were debound at the same time in a traditional kiln. The one difference, though, is the sinter cycle. We opted to go for a shorter cycle with a lower max temp. I already showed it, but the last attempt ended up with a big rocky mass, which was unusable still. So again, this is the refined blend, modified blend to hopefully allow for separation from the ballast, and then we'll, if so, we will attempt arc sinter. So fingers crossed. Let's see what happens. So as suspected, the lower temperature did allow for the element to be removed. However, it might still be... It's still a little hard down here. I don't know if I'm going to be able to excavate this. We'll see. The ballast experiment might be a bust, but we'll see if we can get this steel part out of here anyway. So hopefully I don't have to break the crucible like last time. I'd prefer not to have to make another one, so fingers crossed. Well, I tried to use a hammer. I shouldn't have. Should have kept with the sandblasting technique and used the Dremel, but knocked out the bottom. Anyway, this is looking really good. We'll see if I can get this completely removed from the shell here, and then we'll give it a arc center. But as you can see, the shape is very good after a just a single hour of pre-sinter. Pardon, I'm also wearing a dust mask, so it's a little hard to hear, but anyway, I'm going to go ahead and blast this with the sandblaster over there, and we'll try to get this cleaned up. Okay, here's another pass of cleaning. As you can see, we've achieved most of the cleanup, but these little stubborn bits need to get off. Hopefully I don't break the part. In between, it's looking very good. I would like to, very much like to arc center this and get some tests on this before I do that, but it looks very good if I can get the bits of rock over here off. So I'm going to continue cleaning up with a Dremel and maybe some hand files. Wow, look at that. Nice little piece of 17-4 steel. I've got a little melty bits, so it looks like the sinter cycle actually went a little too hot for what I was trying to do. Again, keep in mind this was supposed to just be a pre-sinter, but with the new ballast, my hunch is a little correct. I think the environment produced possibly reduced some of the requirements for sinter, and well, here we go. This is just a single hour of microwave sintering, and again, there's still some a little bit of melty bits and ballast stuck in here, but all in all, this is a very, very good part. I still think I'm going to do an arc center and see if we can improve this at all. I mean, it looks good to me, but now that I have it, smoke them if you got them. I might as well just give it a shot and see what happens. Arc media loaded. Go into the microwave. Put our lid. And we'll go ahead and get a cycle going. I'm going to do 2-minute bursts. 100% power level. Position center in the microwave. And you'll notice immediately the arcs forming. Can you see that flicker? Now what we're going to do, after 2 minutes, we will rotate. Move some of this stuff out of the way. We're going to rotate the crucible, quarter turn, and do this again 2 or 3 more times. The temperatures in there are extreme. But after 6 to 8 minutes, we'll be done with the arc center, and then we'll see what our result is after that. Okie dokies. Well, it's still a little warm, but I think it's cooled off enough that we can try to handle this piece. I'll get one of these spare center lids over there and use that to set the little piece on. Again, it's just a little test ring, so we'll be able to pull it out with tongs. For anyone that's stuck with me this long, thanks. I feel like I'm very close. I know sometimes it feels like I'm the only one doing this, and who cares? But I know there are at least a few other people out there in the world that find this a little interesting. So, again, the goal here is low-cost, additive manufacturing with just some humble tools. And again, this is 17/4 steel, but I think this is capable of translating over to titanium or possibly even more exotic metals like tungsten, or really anything that requires high temps. So those arcs get again extreme. So there's some definite possibilities out there. Anyway, enough of me blabbering. Let's open this up and see what we got. Alright, not the wisest thing in the world, but I'm going to extract and film at the same time so you can kind of see what I see as I see it. So the one thing you'll notice here is that the arc media has essentially been consumed. There is, looks like a little piece of aluminum there still, but for the most part, I've got that down to about 6 to 8 minutes run time, and that's consumed. The carbon here, pretty much untouched, because the immediate step after taking this out of the microwave with the air porous ceramic wool lid is to put the regular lid on top. So let's see what we got. The ballast is easily separated by the tongs, which is very good. Exactly what I need, which is why I'm doing this in a two-step approach. Alright. So this, let's see. That was sticking to the top there a little bit. Alright, here's our piece. This is pretty hot still. Okay. As you can see, it is coming out just fine. No clumping of the ballast at all, which is exactly what I wanted. This is still very hot, so it's got to cool down, but it definitely doesn't look worse. I don't know the properties yet, but we'll find out once this actually cools down. Okay, this is straight out of the sandblaster. Cleans up pretty good. Feels good. Definitely feels good. Let's see if it polishes and it has any any better electrical properties. I didn't really show it the last time, but the pre-sinter part I think was getting anywhere from 10 to 20 ohms resistance, which isn't, I think that shows the porosity. So we'll see if this is any better. But I'm gonna see if this polishes up a little bit with some sandpaper, and well, let's see what it looks like. What a pretty sight! Look at that. That looks really good. All done just in the microwave there. I mean, sure, we have some boogers over here with the pre-sinter, but all that's going to take is just dial it down a little bit, and then arc center, and we get something like this. Just so you see it, it's definitely steel. Yeah. Alright, now we can test the resistance if you'd like. That's, you know, why not? Okay, it's going to be a little hard to show. I didn't really prep this setup very good, but maybe you can see that. We'll zero everything out. Alright. Nine, 10 ohms. Let's see. Three ohms, 2, 3, 7. I mean, it's, again, you got to keep in mind this is sintered metal here, but prior to the arc center, we were getting anywhere from 20 to 30, so it's a noticeable improvement for 6 minutes. So perhaps this could be done for another 6 minutes and even further densify this part, but you know, overall this is a big success for me. I'm really happy with this. It feels great. Just so you can hear it. That is a really good result for me. I'm super happy about this steel part. And again, I think the benefits are there. We're talking about just an hour pre-sinter and 6 minutes arc center step here for you know, a fully solid part here, and this is what it looks like unpolished, but that's the other side. So polish this, and that's what it looks like. And this is strong. I mean, this is steel. I'm really excited to try this out with some other components and pick this back up with aluminum. I've got an aluminum test lined up next here to see if this applies to that as well. And well, anyway, thanks for tuning in. Sorry for the long video, but takes a long time to do this stuff. So anyway, I'll catch you in the next one. See ya.